So the next lesson continues with multiplying polynomials, just a little bit differently here though. Right here it says Jeremy has noticed a pattern that he thinks is always true. If he picks any number and finds the product of one number larger and one number smaller than it, the result is always less than the square of his number. Okay, what does this mean? So the first part says test some numbers and see, right, if his pattern holds true. So if we take a number like 6 and we square it, we would get 36. If I take one number less, which would be 5, and one number more, which would be 7, and I multiply these together, I would get 35. Is that one less than that? Yep. If I try another number, say 8, well, 8 squared is 64. 1 less is 7. 1 more is 9. That gives me 63. So does his pattern hold true? Yes, it does. So it says, give an algebraic expression that shows that Jeremy's pattern will all work for any number. All right? So if we take this and we say, we're going to let the number be x. Okay? And if I take x squared, right, that's the number squared, that should equal, if I take that number and add 1, right, that gives me one number larger. And if I take the same number x and subtract 1, that would give me one number smaller than it. Okay, now, this should hold true, but how does it end up being one number less, right, than the number squared? Well, I'm going to take this and multiply it out like we just did. X times x is x squared. X times negative x, or x times negative 1 is negative x. This is going to give you positive x. This is going to give you minus 1. What happens is when I add the numbers in the middle, I end up getting x squared minus 1. And if you look, that's the number squared, and you're squaring that number and subtracting 1. So this, right, ends up being equivalent to x plus 1 times x minus 1. Now, what this ends up being is called a sum and difference, right? And if I take a plus b and I multiply it by a minus b, and what we're basically doing is we're adding the two terms and subtracting the same two terms. And when I multiply it, what happens is I get a squared minus ab plus ab minus b squared. And these middle terms eliminate, leaving me with a squared minus b squared. What happens in a sum and difference is if the two terms are the same in each binomial, one's linked by addition, one's linked by subtraction, the middle terms will always eliminate when you distribute. Okay? So you can get away with just doing the first term squared minus the second squared term if you get it. So, for instance, if I multiply this out, I would get x squared minus 4x plus 4x minus 16. Middle terms canceled. I end up with x squared minus 16. That's no different than taking x and 4. If I take x and square it, I get x squared. If I take 4 and square it, I get 16. And it's going to be x squared minus 16. Right? So you could do it either way. So right here now, I'm just going to basically multiply the first terms. That gives me 9x squared. The last terms minus 4, and I am done. Okay? Now again, this only works on a sum and difference. Okay? So take a minute, try these, come back, check your answers. Well, two same terms, one linked by addition, one linked by subtraction. This is going to give me x squared. This is going to give me minus 81. Done. Here, you're going to get 100x squared minus 9. Done. Again, if the terms are the same, one's linked by addition, one's linked by subtraction, you can basically get away with the outers and the inners. Okay? Now, which of the following expressions is equivalent to, this should be x plus 7 all squared? Verify your prediction by plugging values of x into each of the expressions, evaluating the expressions to check for equivalent values. So what they're basically saying is, if I plug numbers in for x, so say I let x equal 1. 1 plus 7 is 8. 8 squared is 64. If I do 1 squared here plus 49, that's going to give me 50. That doesn't work. If I do this, 1 plus 7 is 8 times 1 plus 7 is 8. That gives me 64. That checks out. Right? 1 minus 7 gives me negative 6 times 1 plus 7 gives me 8. Negative 48 doesn't work. 7 times 1 is 7. 7 times 1 is 7. That would give me 49. That does not work. Okay? Now, we know we could take this binomial squared and expand it out and write it as x plus 7 times x plus 7. Continuing with this expression, right, can we do the distributive property twice? Meaning, can I take x plus 7 times x plus 7 and multiply it out? That's going to give me x squared plus 7x plus 7x plus 49, which in returns would give me this. Now, you can always use this method to simplify that expression. Okay, you can always do that. Now, is there a shortcut to go from this to this? We'll talk about that in a minute, but they want us to test this equivalency to find the value of x plus 7 all squared and x squared plus 14x plus 49 when x is 3. Well, 3 plus 7 all squared gives me 10 squared, which is 100. Here, 3 squared plus 14 times 3 plus 49 gives you 9 plus 42 plus 49. When you add those together, you would get 100. So what they want you to see in this part is this is equivalent to that, right? Either of them, both of them are the same. So how do we square a binomial quickly then? If I have a plus b all squared, I know my first term is going to be a squared. Then to get my middle term, I'm going to multiply a and b together. And then, if you notice, if I multiply 7 and x together, right, I get 7x. But how do I make that 14x? I double it. And then my last term is just plus b squared. If I have a minus b squared, it's still a squared. It's still plus b squared here. But a times negative b would give me negative ab. And when I double it, I get minus 2ab. Okay? So, if we look at a couple of examples here, and again, if you don't know this shortcut, right, you could always expand it out, right? So you can either use a shortcut or you could write it out like this and multiply combined like terms. Doesn't matter. But using the shortcut here, right, I'm going to take x, I'm going to square it. I'm going to multiply these together. I'm going to get negative 10x. And if I double that, it's going to be minus 20x. Then Negative 10 squared would be plus 100. If I were to write this out, just to show you, x times x is x squared minus 10x plus 100. That would give me x squared minus 20x plus 100. No matter which way you do it, you get the same answer. So for the next one, 3x all squared gives me 9x squared. Right? Now, if I multiply 3x and negative 4, so it's 2 times 3x times negative 4, it's going to give me 6x times negative 4, so negative 24x. Then negative 4 squared will give me plus 16. And we are done. Okay, so that's the shortcut for squaring a binomial. Do me a favor, attempt the homework, and let me know if you have any questions.